So, here we go. Let's try some subtracting rational expressions. Our quick reference guide for subtraction really isn't any different. We're going to be doing the same things. Always factor denominator. After that, you want to determine your least common denominator, write equivalent fractions, multiply and distribute. This is where it gets a little bit different, because when you distribute, you're going to have to distribute a negative, so you got to be somewhat careful about that. And then collect your like terms. So let's just work through question number 1 and see how we follow through. The only difference today is that instead of an addition sign, this is a subtraction sign. So whenever we do addition subtraction, we have to get a common denominator. But before we get a common denominator, we must factor the denominator. So let's do that. Okay, so Austin, what does this first one factor into?
X plus 4, x minus 1.
X plus 4, x minus 1. Okay, so that's factored correctly. Trinomials factor the binomials. There was no monomial in it. And then the other denominator, Mike?
X plus 4, x minus 4.
X plus 4, x minus 4. So we just factored the denominator, so now we're going to go through and we're going to determine our least common denominator. So I'm just going to change formats a little bit because we can reduce some of our writing if you can understand what I'm doing here. What is the least common denominator for this fraction? Okay, Trevor, you want to take a shot at it? Go ahead.
Yes, your problem.
Okay, we have an x plus 4 in both denominators, so make sure your common denominator has that. What else do you need?
You need the x minus 1 on the other side.
We need an x minus 1, and there's our least common denominator. So we established that least common denominator. Now we're supposed to write equivalent fractions. To write these equivalent fractions, what we're going to do is we're going to compare. How does this denominator compare to our least common denominator? Does it have everything that it needs? What is it lacking? This denominator is lacking the x minus 4. So that means whatever's in the numerator, this fraction has to be multiplied times. So the top and bottom. So the x minus 2 has to be multiplied by the x minus 4. Now, did you notice when I put the x minus 2 in parentheses? Why did I have to do that? We have to distribute. And this fraction bar is an automatic what symbol? Grouping. This x minus 2 must be multiplied times the x minus 4. Okay, then we hit our subtraction sign. So we'll record that. Then put your 5x. What does the 5x have to be multiplied by to create an equivalent fraction with our least common denominator?
X minus 1.
Sure, it's missing the x minus 1 that we have down here, so times x minus 1. Now, did I put the 5x in parentheses? Why is it not that big a deal? Because it's a monomial. If you do put it in parentheses, it ain't going to be a big deal, but typically we don't with monomials, so I'm going to take them back out. So after we get done writing equivalent fractions, now we're to multiply or distribute. You see some distributing that you can do. Yeah. So hand run through our distributive property on this.
X squared minus 4x minus 2x is 3 negative. And then negative, or 8
Plus 8. I'll leave that for just a little bit. This is going to be all over this least common denominator. This is the part that you got to be really careful with. When we start doing this last part back here, and we distribute, what would be the wise thing to distribute here? The negative 5x. If this thing sitting here is a monomial, always take the sign in front of that monomial and distribute it. So if we distribute this, what do we end up with? Negative 5x squared plus 5x. Ooh, that's the only difference we have between addition and subtraction right there.
So if it was binomials, you put distribute the negative to the first pair parentheses first, and then you do that next time. Oh, okay.
Okay, so now we're going to collect our like terms. If we collect all of our like terms, how many x squareds are there? Negative 4x squared. How many x's do we have? Negative 1x and plus 8, all over our least common denominator of done.
So what's the only difference? Subtract 4.
You got to deal with that negative sign here, which means you're going to have to distribute to the things behind it.
That's all we do? Oh.
We change subtraction into adding the opposite. So we're really adding the opposites of these, in essence. So let's drag another example down here, 2. Mr. Anderson, what's the first thing that we do with all of these factors? So let's factor this denominator. What does x squared minus 5x factor to? Is there a monomial factor, Michael?
No. Oh, so x. So put an x and then x minus 5.
There you go. Be really disciplined to factoring monomials out first. Okay, after that, Kara, how's the second one factor?
X minus 5 times x plus 1.
Good. Kyra, let's work on that common denominator. What is it? Let's build it.
Well, since you have the x minus 5 on both sides, so that's definitely one.
Yep.
And then the x plus 1, you move it to that side.
Okay, we need an x plus 1 in our common denominator, don't we?
Yeah.
And what else?
And an x.
So we got them all covered. Okay, so you just found our common denominator. Nate, what are we going to have to end up multiplying this x plus 9 times? Compare this denominator to the common denominator we just created. What is it missing? Yeah. See how this does not have an x plus 1? It needs it. So we're multiplying an x plus 1 on the top and the bottom. So times x plus 1. And we have our new change days, the subtraction sign. Okay, now what, Landon?
Now you go to the other side and you take it times x, and that 3x minus 4 is x.
Okay, the 3x minus 4 that was already here. What is this denominator missing? You correctly identified it as an x. Now I can put it 2 locations. I could put it back here, but where are we more comfortable distributing?
To the right, like to the right.
On the front side, the left side. Right. Next stage. Cody, you with us? All right, what's the next thing that we're going to do with these 2?
You asked me?
Yep.
Okay. Well, we're gonna do, well, those 2, you just, distribute.
Okay, so what do you get when you distribute?
X squared.
Then,
X.
then, and none. All right. You got this, Ralphie? How about the next thing?
There's 3x squared plus 4x.
Perfect. What did he distribute?
Negative.
That negative x. It's a monomial sitting in front of here again, so distribute it along with all over your LCD. And now we'll collect our like terms. So let's go put all our like terms together. Okay, so negative 2x squared plus 14x, if I am hearing you right, plus 9. Done. Okay. Had another example here that we can run through, and then we're going to do a what if on one of these so you can figure there's one little twist yet they don't have in these 3 examples. This is our 3rd example. Huey, what do we do first?
Factor or
It's a good word. Factor the what? And what comes out of this x cubed and 9x?
x.
So you factor out a, you got your finger on that word yet? This is what kind of factorization? M word? Monomial factor. Oh, come on, we got to keep working on that. Then this becomes what, Brooke?
X squared.
X squared minus 9. Chris, are we done factoring that one?
Yes.
Look at it again, Chris.
No, the extra last sign can be factored into x minus 3 times x plus 3.
Good. Even after you factor out your monomial, I keep telling you, don't give up on them, because what was left was the difference of two perfect squares. One is not done sometimes. Sometimes you gotta do layers of factoring. So this is our denominator factored on the left. We're gonna take the right denominator factor.
That would be x plus 3 and x minus.
Okay, so that's that one. Just gonna move it down here in that level. Well, whatever, it sits there. Now we're gonna create a common denominator. Who wants a common denominator? Go ahead, Mike. What do you got?
X minus 3, x plus 3.
I think I have a misprint here. One's a plus, this one's a minus. Okay.
X plus 3. X minus 2.
It's a lot of stuff in that denominator, but that's how you're going to build your common denominator. They have this component already in common, then we need everything else that didn't get paired up. Hey, come on, Amber, you picking this up? So I got a 2x minus 5 up there. Should it be put in parentheses or not? Yep.
Yeah.
Fraction bar is a grouping symbol. So that 2x minus 5, we're going to have to multiply that times. What do we need to multiply it by if we already have an x plus 3, and x minus 3? All we're missing is the x minus 2. Then we run across our subtraction sign. Then we got an x minus 1. I'm going to put it in parentheses right away. Now I got to figure out, what do I have to multiply this times to get our common denominator? What is this missing? It's missing an x and an x minus 3. Perfect. Now we're set up to distribute. Let's distribute this. Go, Nate. Minus. Okay, so we just did that. Now let's talk about what we're going to do here. How many numbers are we multiplying together? 3. When you multiply numbers together, at most you can multiply at any one time is how many? 2. Now it really doesn't matter which 2 you want to multiply together first. It's your choice. But once you multiply 2 of those together, you take that answer and then you multiply it by your third number. So it's a matter of what you want to do. You want to distribute the x first? So some people would prefer to do that, and I'm neither here nor there on that. If you do that, you're going to distribute it one time to one other number. You're only going to multiply 2 numbers at a time, so maybe it's these 2. That would make sense since they're next to each other. So then this is going to be a negative x squared plus an x. Now that's the answer we have to take and do what with? Multiply it times x minus 3.
You don't flip it again, though, do you?
I don't know what you mean by flip it, because I didn't flip anything. I
You
distributed.
don't change the sign.
You don't distribute the 3.
No, now I'm done with that negative. I've already used it. Okay?
Still in, basically.
So now we're going to multiply these together. So this is going to require us to use FOIL. This is negative x cubed plus 3x squared plus another x squared minus 3x. Now that goes down here, negative x cubed plus 3x squared plus x squared minus 3x, and that's all over your what? Least common denominator. We've already done our distributing. After you distribute, you do all of your collecting. So find all those things that are alike. Negative x cubed. You want to put it going high to low in power. So x cubed first, then how many of those x squared do you have?
6x
So plus 6x squared, then minus 9 and minus 3, minus 12x, plus 10. Now you get the joy of writing down your LCD again. Okay, well that's a few of the things that are going to happen to you. Now I'm going to do the old one, what if deal. And I'm going to come back to here. And this is just what if you just would have had this with two binomials.
what?
Again, you have options. How many numbers are you really multiplying together here? Okay, so someone's saying 2, because he only sees 2, and that could be right. You're going to multiply these two together, and then you're going to subtract them, or distribute -1. Or you can say I've got a -1 times this, times this. I could say I've got 3 numbers here, with the -1 being one of them. Now I don't care what camp you're in, but here's my preference. I like sticking that negative sign right out there and waiting until after I've multiplied those two together. So I'm going to do this first, multiply those together, so that's going to be x squared, then minus a 3x minus a 1x is minus a 4x, and it's going to be plus a 3. So now we're subtracting all of this answer. So then you subtract it, you distribute your negative. So in essence, I'm always going to multiply by that -1 sometime, but only once. So then this will be a negative x squared plus 4x minus 3. Those are some of the things that you're going to experience on your worksheet, and that's kind of the end of the story here.